Welcome. My name is Terrence Parkin. I'm the Executive Director of the Graphene Council, and we're hosting today's webinar on graphene in Latin America. We are joined by four excellent subject matter experts, including Flavio Plentz from MJ Grapheno, Danielle Elias from the McGrath Institute at Mackenzie University, Belen Martinez, who will join us from Mexico with Glaren, and Carolina Tegon with Carbon Up, who's also based at the Mackenzie University and the McGrath Institute. For those of you who are not familiar with the Graphene Council, we were formed in 2013, and today we are by far the largest body for this sector, reaching more than 30,000 materials scientists, about 1/3 of which are in the academic community and 2/3 are commercial professionals. We're also involved in the establishment of international standards for graphene materials. Just to give you an idea of who our members are, we represent, as I mentioned, the academic community. We have a close tie with Manchester University and the Graphene Engineering and Innovation Center. And we're very pleased that we established a strategic partnership with Mackenzie and the McGrath Institute to the point where we have now a physical presence in Brazil through Mackenzie, for which we're very grateful. The Graphene Council represents the entire ecosystem, from graphene producers to intermediary companies to end users, most notably companies like BASF Chemicals or Ford Motor Company. Why is graphene such an exciting material? Well, it's because it can be applied to more than 45 major industry sectors and applications. It has an extremely broad range of applications, and in fact, one might be challenged to find some place where graphene might not be applied. The Graphene Council provides expertise in the form of custom advisory services if needed, and we also produce the Graphene Report, a 600-page document that details production methodologies, characterization methods, which was done in collaboration with the National Physical Laboratory in the UK, types of commercial materials, market information, standardization, etc. So it's quite comprehensive. The Graphene Council is established now in the United Kingdom, as well as in Switzerland, and as I mentioned, in Brazil and the United States, of course. We are a Tier 2 member in the Graphene Engineering and Innovation Center, and that means member companies of the Graphene Council can access that facility through us as a consortia member. And like today's webinar, we provide other informative webinars on topics like thermoplastics, composites, or individual company updates. So for those of you who maybe are not a member of the Graphene Council, we encourage you to think about that and being engaged with us as we help you navigate and how to use these graphene materials. So with that, I'm going to invite Flavio, if you would please go ahead and share your screen. We're going to hear from MJ Grapheno first, followed by Danielle. So Flavio.
Yeah, so good afternoon for everybody, or good morning, I don't know where you are. So I will talk about the MG Graphene project, and this project has to do with the production of graphene. We made a pilot plant, but not only production. We also want to make it widely available and really to enable applications to go to the market. We really want to fill that important gap. Okay, so we are in Brazil. This is the Minas Gerais state, where the project is funded by a Minas Gerais state development company, Codenge, and is a partnership of Universidade Federal de Minas Gerais. This is a state university in Brazil. It's located in Minas Gerais. And CDTN, that is a nuclear technology research center, but with a lot of material science, also in Minas Gerais. In fact, both institutions are in the same campus. Okay, Belo Horizonte is here. And why Minas Gerais? Because Minas Gerais, in this region of Minas Gerais here, there is a lot of graphite and very high quality graphite. So the idea of the project was to, to take this graphite, all this opportunity, and make it more valuable, from the technological point of view. The principal investigators are listed here. So Adelina Pinheiro and Clacidia Furtado are from CDTN. Myself, Flávio Plentes, Luiz Gustavo, Omar, and Bernardo, we are all from the physics department of UFMG. And Guilherme Lenz, is from Metallurgy and Materials Engineering from USP, Universidade de São Paulo. And Valdirene Perecinoto, is the coordinator of the project at Codenge. So in numbers, so we are today 62 people, 22 PhDs, right? And this is just an overview of the project, all the team. This is in fact inside the place where the pilot plant is operating, and this is now a short view here of the pilot plant as it is now. So Codenge is the development company of Minas Gerais. This company established a partnership with UFMG and CDTN. Graphene, of course, now is considered a key material, and the idea of Codenge was to use all this availability of high-quality graphite in Brazil, and transform this into graphene, into a technological material, and then use that to foster a new industry and a new economy in Minas Gerais. So the initial investment was about 21.3 million reais. This is about $4 million. And the project has now a capacity of 150 kilos per year, but this is not being really updated to 300 kilos per year of graphene. And at the end of the project, you'll be producing like 500 kilos per year in a pilot plant, but in a readily scalable process. Okay. And there is also a company, this NeoGraphene company, is being implemented to really exploit commercially all this technology. And the idea is really go from mining. This is already a very well established industry in Minas Gerais, especially in graphite. Minas Gerais, if I'm not wrong, is the third exporter of graphite in Brazil. There is a company there, Companhia Nacional de Grafite, that is responsible for all this production of high quality, really high quality graphite, and then transform this into graphene, and of course, produce also technology solutions and industrial applications. So the project and the whole business around the project is not to produce graphene, but really to make it like a technological asset that you can use to really foster applications and foster new industries. So it's much beyond not only the production of graphene. This is a vision of the pilot plant as it was like 1 year ago. So it started in 2016. It had the phase one, that is where this is really the development of the pilot plant, all the separation process, all the characterization. That is a very important part of our project. Now we have a very comprehensive and a very strong characterization framework for the graphene. We are now in phase two of the graphene. So this is really where we are getting in touch and in cooperation, close cooperation with companies. So this phase, in Graphene 2.0, will take all the graphene, all the quality material produced here, and really enable the applications here, because we can really supply this in quantity. So we really have now the capacity to send to our partners, as we indeed are doing already, so that the partners can run the material in their pilot plants. So we are not doing anymore like small benchtop demonstrations, but we really have partners that are taking this material, putting this material in their pilot plants, polymers and whatsoever, and running. This is in a pilot scale in the industry. And this is the whole idea of the thing. If you really want to scale up, you have to be able to have quality material in enough quantity to allow the industry to also run their pilot plants runs, and tests. And then phase three is really go to the big market. So and then requires, of course, more investment. But here we really looking, and Codenge is actively looking for private industrial partners. So here are the numbers invested in phase one, and the amount that is committed to phase two of the project. Okay, so in numbers, we have a very good conversion rate from graphite to graphene, and what we call graphene here is few layers graphene, I'll show you, and graphene nanoplatelets. So 10% of all the graphite that enters the plant becomes some sort of graphene material, and 88% is converted in what we call nanographite. There is a finely exfoliated material with more than 20 layers, and this is, of course, there's a very high capacity, but it's a very interesting material. And I will call your attention to this. All the plant, everything in the plant is environmentally friendly. All the water is treated, all the material is treated. The water that goes out of the plant is better than the water that came into the plant. So there is no waste. So it's really a very environmentally friendly process. We made a lot of effort and put a lot of investment to make this environment-friendly process. And the idea of neographene, these are the main things. Okay, first, very transparent characterization data sheets. So this is a key factor, and this is what we saw, and we still see it, as a weakness of the market. So we did develop a very strong and transparent characterization matrix and data sheets. We are reproducible from batch to batch. Okay, we can demonstrate that, very convincingly, and we have to have compatible application compatible cost. So we are looking here at a cost breakdown points from $20 to $50 per kilo. We are not there, of course, still, but we have indications that we can get that in the scale up. And also customization. This is also key to the industry. You have to send to the partners a graphene that they can use and a graphene that is suited for the application. So in the end, we want to reduce the risk of industry, of partners to go into this market, look upstream in the value chain, and of course share the profits for enabling the partners of putting new applications and gaining market. So in the end, you must hear a lot of what is high quality graphene, what's low quality graphene. But in the end, the graphene is as good as the applications that it will enable. So they are a very, there is many types of graphene. It's a variety of materials, in fact. So the graphene has to be good enough, and has to suit to some applications, and each application will require a type of graphene. Okay, so the production process, I won't talk very much about this, but we have the preparation of initial suspension, so graphite, water, plus additives. So we have the typical chemical, mechanical assisted exfoliation. We have separation processes, so we put a lot of effort here in the separation process. We really developed very, very good separation process for the material that is generated here that we call conversion. And then the post-separation. So we also developed drying, concentration, what is very interesting. Right now, we can take a suspension of graphene and concentrate it up to 3 times. So we start with like 0.6 grams per liter, and we end in the suspension with 2 grams per liter of high quality graphene. And we also are doing this functionalization, customization, and of course, the treatment of residues. Okay, and we do that with the graphite supplier, that is the National de Graphite Company. Okay, so the graphene products, we have this few layer graphene. So this is up to 5 layers, centered in 3 layers. The production here is 90 kilos per year right now. The graphene nanoplatelets, that we call, so it's up to 10 layers, centered in 6 layers. So this comes out as a powder or a cake. This comes out, originally in water dispersion, but we can dry it, okay? And this is 210 kilos per year, and the nanographite. So this is a small graphene flakes finally exfoliated, 10 layers and higher. So this comes as powder or cake, and this is 2.6 tons per year. So we have all these 3 basic materials, but from these 3 basic materials, you can, in fact, generate another variety of materials depending on the finishing of this product. Okay? So this is the fuel layer graphene from the TEM point of view. So stable water suspension with 0.6 grams per liter concentration. So of course, this is not statistical about the material, but we do frequently TEM of all the materials to check on number of layers, on crystallinity, and things like that. So this is the graphene nanoplatelets. So this is the material that comes, that we call from 5 to 10 layers, how the material looks in powder. So this is deposited, of course, over substrate. So this is the ECM images of the material as it is. So you can see that's really very finely exfoliated materials. And this is the nanographite. So this is how it comes. So you can see here a very nice picture. So you can see that this is like a partially exfoliated material. You can see that the planes are beginning to be separated, but the exfoliation process has not been completely done, but we have this nice material also. So characterization, information is everything. This is very key for our process. So we have a very large characterization matrix. I won't go into details into that, but I'll show you something. When we do AFM, for example, we don't do AFM in 100, in 200 flakes. We do AFM in thousands of flakes, in 10,000 flakes. And this is really the picture of the material. This is what you really get, and this is what you can see. It's really statistical measurements that you can rely on. So the real material is this one. So its number of layers is around 4 in this case. The lateral size is around, centered in 90 nanometers, for example. Okay, so we do that for every batch. So how we do that? We built a completely automated characterization system that can pick up all the data. You measure the samples, the batches, you download it to a server, and in the server, everything is done automatically. All the analysis, we use artificial intelligence. There is a very nice and very important contribution from Omar Paranaíba from the computer science department that built all this framework for us. You can go to any flake in the image, see what flake is this one. So this is a very so this gives you the customers and us, the producers, a very high degree of confidence in the material. So we also put always Raman and AFM. The Raman is also the analysis is also done automatically. So we can also see the material depends how you look at it. So the AFM will be more sensitive to the morphology of the material, and that the Raman will be more sensitive to the electronic coupling between the layers. So you can't measure Raman and say, okay, my material is two-layer. This is not true. It is two-layer from the point of view of the electronic coupling between the layers. But it is more than two layers. It has like 4 layers, and it has a distribution if you look to the thickness of the material. So what this means? This means this is a material with 4 or 5 layers, but in this material, the electronic coupling between the layers is on average of 2 layers. So this is the kind of thing that has to be put in the data sheet. And what we have to do is to make all this very transparent. The customer has to know all the information, how the information was obtained, and what is what it means for the customer, for his application, and what it means for the batch-to-batch reproducibility. So we have really a very strong characterization framework. Besides a very good production process and separation process, everything together, we have a very good. So we can do this for the water dispersion. We can do this for all the material produced, for the few layer graphene. We can do this for the dried material. So we always can redisperse the dried material and do the FM, and everything is put into the characterization sheet. And also, as I said, if you take a suspension and you make different separation process, you can get different materials, where you can see here, right, in this case. For example, when you look at the TG, the thermogravimetry, if you change a little bit, the separation, you go from a burning temperature around 600 to a burning temperature very sharp at 540. What this means? This means that you can customize the graphene. Of course, here we have 0.2 grams per liter. But this might be good or will be good for some kind of applications. Here we have like 0.7 grams per liter, and this will be good, will be nice for some kind of application. So this means that you can deal with our material, we can modify the material, we can customize the material, and this will work constantly with our customers, with the companies, with the research institute that are working with us. Okay. So this is what I said. This is a completely environmentally friendly process. We put a lot of effort in this thing. And in the end, the idea, is that the process will be a closed process. So all the water that comes out comes in again in the process. Okay. So this is what I said. We work in the 4.0 industry mentality, mindset. So everything is automated. We have traceability in everything. We try to put real-time decision making into the whole process, into the whole project. So this is what done, as I mentioned, with the cooperation of the computer science department. and all the projects integrated within a single system. Okay. Of course, now you have to produce graphene, you have to show that the material is applicable. This is very important, so we do that through co-development and through internal developments. So we have over 26 companies, we have about 20 NDAs, several MTAs, material transfer agreements. So we are actively working with partners. We have exported already, graphene to Spain, to Germany. So we know how to move the graphene around. This is very important. Take graphene from Brazil, put graphene into Europe, for example. And being with all the regulations, it's very important. We also demonstrated several applications in the project. Of course, I don't have time to go through this, but our graphene can be applicable, and we really demonstrated the material is applicable in the main applications of the material. This is an example for anti-corrosive coatings. So with only 0.1% of addition of graphene, you see the blue curve here, you have like 3 orders of magnitude increase almost in the corrosion resilience of the coating. So we have these demonstrations. We are working with partners into this. And this is the graphene project as it is now. So we established a pilot plant. The pilot plant now is bigger. Now we can produce much more graphene than a year ago. And the main area now is really scaling industrial application in partnership. So all the efforts of the project now are really concentrated in applications. So our team will have a specific team for applications, for contact companies to understand their problems, to take their problems to be studied by our teams, and really to produce a cooperation that will, in the end, lead to a viable, this is a very important word, to a viable product. The product can be nice, can be very appealing, but it has to be viable. Okay, it has to be cost effective. So that's it. It was very fast. I apologize for that, but we are open. You can contact us at any time, to learn any details, and we are readily available, full time basically. Okay,
Flavio,
so thank you very much.
Flavio, thank you so much. That's an excellent presentation. There's obviously quite a lot going on, and I know we're going to have some questions for you when we get to the Q&A. So Daniel, when you're ready, if you're able to share your screen, we'd love to hear about what's happening at McGrath Institute.
First of all, thank you, Terence, to invite me to give this talk. And it's also I'd like to thank you to do this partnership with us here, and I'm really happy to host Graphene Council office here in McGrath. Hello, everybody. My name is Daniel. I am Research Development and Innovation Manager of McGrath here in São Paulo. But before to talk about McGrath, I wanted to say that McGrath is part of Mackenzie Institute. And Mackenzie Institute, it's a 150 years old institution, which the core business of Mackenzie is the education. Before that, I would like to say that it's a non-governmental and non-profitable institution, which is very dedicated to the education since the kindergarten to the post-graduation. And we also have several different programs of research, development, and innovation, such in different areas like radio astronomy, digital TV, neuroscience, hospitals, and so on. and we have a company in different places in Brazil. And here I can show you only some of the examples we have. All right, so the MacGraph is one of the institutes that it's equipped by Mackenzie. We are not part of the University of Mackenzie. We are institute independent of the Mackenzie University, but we are inside the Higienópolis campus in São Paulo. So we share the same environment of a University of Mackenzie in São Paulo, which is really, really good. And because of that, we share professors with the university. So if you see the head count of MacGraph, we have 12 professors of the university that are inside of MacGraph doing the research and participating of the developing and innovation research we do here. So we have a 10-floor building with 31 labs, and we do R&D. We have the administration, auditorium, and reception. And we have grad students, undergrad students, product research, and all staff here that helps the building to keep going on. Through our history, we built up several different partnership and network with different universities in Brazil and abroad, and also Brazilian force, American force, also companies that already talk with us and start developing projects with us, and also people from government that is already talking and doing work with us. Talking about the activities that happens in the MacGraph, since the MacGraph is inside the university, we have a plenty of academic things happening here, research and orientation of students. We have the research, development, and innovation where we bring the industry together with us. When we want to talk with in the industry, we want to know their problems, and we wanted to develop innovation with them. And we have our programs that we recently announced, which is the one-day workshop, the MacGraph Partner Program, and the MacGraph Open Lab that I'm going to explain you a little bit better soon. Starting with the academic part, our experts here, they are acting in different areas, starting with photonics, electronics, and device, where the MacGraph really started with Professor Toro and Cristiano. And also it comes with different professors that joined the team. They start in 2012 and start joining other professors and acting in different areas like energy stores, sensors, biosensors, composites. I forgot to put it here, also membranes and filtration, production of graphene and other 2D materials, characterization, and metrology. In the RD&I projects, so the idea here is to do more than the academic research and try to scale up the research we do here and try to reach what the industry really needs in order to put the ideas that comes from the academic to actual production and put everything that we do here, or not everything, but something that we do here in the production, in the market. So we know that in the universities is where the plenty of the ideas come and plenty of the works and design and the planning, and a lot of things that happens since the TRL 1 until TRL 3. And from the side of the industry, plenty of productions and prototyping and testing until they release the products to the market. And in a developing center is where the people start to scaling up these productions and building, testing, learning until they find this minimum viable product. So there is exactly where MacGraph wanted to act. We wanted to take this idea from university. We wanted to hear what the industry wants. So we have the entire workflow, or how we build the project with the industry. Then we come with our experts from the university here that they working with us here in the Macgraph. Then we start to build up, the projects, and then we started to build up this prototype until we get this minimum viable problem. Then we can put that in production, and we can assist the industry to really do something with the research we do here. And for that, we divide the research in Macgraph in 4 different areas, what we call nanomaterials, nanotechnology, device and systems, characterization and metrology, market and management. The idea here is to assist, to prepare the nanomaterial to, especially the 2D materials, and also functionalize and prepare its material to actually do the technology, and not also to do this technology like functionalization, but also to build up devices and integrate those devices to larger systems. And another side that's really important for us is to do the proper characterization and to help the research to find the trustful material to apply in their products, which is, we believe that's really important. And in the end, we also comes with this area, which we call market and management, that we help also the industry to do that research that can be helpful for them. So when we think to develop some product to the industry, we don't want it to do that with that excellent materials and graphene oxides or graphene that comes from the bench of a researcher. We really wanted to go to the market and study what is available and what's the price of this product in the market, and see if that's really this is really viable to develop this product to the industry. So that's really important for us. And of course, one project that we developed with a company can, be in several different, all 4 different areas that we have here. And to build up this project, we provide the technical support, the administrative assistance, and our PMO, and everything that is really important to things going on. To talk about our programs now. So starting with the partner programs, we believe that long-term relationship with companies can be really helpful to bring good ideas for companies and also for the academic side. So for that, we developed this partner program. It has 2 categories, the partner program 1 and the XPE. The 1 is for large budget companies that really wanted to invest and put a lab inside our institute. The XPE is for a small budget or for companies that doesn't have that much money to invest, but they wanted to use our shared facilities and they wanted to do their research together with us. Half of the money they put here to work, they can, it will be allocated to develop the research, and the other half is to pay for the structure they use in here. So here's a little bit information about the program, how it works, and how what's the idea behind the program. I'm not going to read everything here. So after the talk, you can download the PDF to read. And here's the map of our 60th floor. So just for you to have an idea, here is where we are going to allocate our partners. So we already have a partner here, and we are already discussing to another 3 partners, 2 XPEs and 1 and one partner one. So for partner one, they will receive this 30-meter square lab to locate their private lab to do their research, and the XP, they will be in this work this co-working area, and they can use the shared facilities in the below floors to do their research. Going on to another very important things that I wanted to talk. So we have two partners that can be quite handy for our partners from partner programs and other companies that can come here and talk with them. One of them is the Graphene Council. So they will be here in the 7th floor, which is the administrative floor of the of Macgraph. And they will bring the intelligence to Graphene. So it's if you wanted to know about the Graphene chain, they are here. So just come, and we're going to announce soon how to contact them in Brazil. And they will be here in the Macgraph. And this Blue Fields, it's a startup acceleration company that it's also here in the 7th floor. So if you have a startup, if you wanted to accelerate your startup, talk with them, they will help you to accelerate your startup. Then you can bring your startup to here and you can develop your product together with us. We have our one-day workshop. The idea here is if a company wanted to know more about graphene and if they wanted to bring their chain of supplies to know more about graphene, they can come to us. We can design, a whole day of seminars and a discussion set. So we start the very early morning. Then we have a coffee breaks, lunch, and seminars and tables of discussions in the whole day. And in the end, the idea is to have more opportunities, of developments with the companies. During the pandemic days, we are doing that via webinars, but after the pandemic, we're quite sure that we can do this in our auditorium here, which is a very nice place in our 50th floor. We also have this Macgraph Open Lab that will be announced the next year, which has this characterization lab and the shared facilities, that 2 floors that we're going to dedicate for that. So characterization lab for dedicated to nanomaterials, specializing in 2D materials, shared facilities to set up experiments, a class 1000 clear room to do devices with laser write lithography and also e-beam lithography. And we're going to have also a mass spectrometer lab with 8 spectrometers and a specialist here that will assist the people that wanted to hire us to do analysis. So at last but not least, just to talk about recent announcements that we released. So sorry about the Portuguese here, but we recently announced a very good result from a partner we have. The name is Gene Testil, where we developed with them a composite with graphene oxide. And with this composite, they did a textile, which the main idea is to have a better resistance, mechanical resistance, but it came out that it also has antiviral property, which is quite handy nowadays. And also, we started developing a partnership with the MCK Graphene, where they will install together with us an industrial plant of graphene oxide in Brazil. Okay, so thank you again. So anything you want, please keep contact with us here, my email and our email here. So
Daniel, thank you so much. Appreciate the presentation. Just another example of how much is going on in Brazil. And we'll come back to you with some questions in the panel discussion. So now we're going to move
thank you.
a little bit further north to Mexico, and we're going to hear from Belen Martinez from Glaren. And we're going to have a little different focus now. This will talk about commercialization of graphene and some practical issues about how do we get graphene in the hands of commercial customers.
Good morning, everyone, or good evening. I don't know, depending on where you are located. Thanks, Terence, for the invitation to present today. My name is Belen Martinez, and I am the CEO of Glaren, a graphene distributor company. And I would like you just to take some seconds to imagine 12 months from now, once things normalize from the current environment, and your greatest competitor comes out with a terrific product that has more resistance to corrosion or to mechanical wear, or is lighter and has additional properties such as electrical conductivity. And when you analyze the product, you discover it has graphene on it, which allows your competition to get ahead. Would you take action today or when it's too late? My purpose this morning is to let you know that Glaren can be a strategic partner for you to get you above the competition by two means. By distributing the best quality graphene for the development of your products at a very affordable price based on your volumes at the lead time required. Secondly, by connecting you with people and resources to help on the development of this new pipeline. As a result, my hope is that you choose Glaren for your new graphene product pipeline to expand your business and grow it from where you are now. Here's how we'll do this. I will cover 4 key points. First, our business focus, then our offer, our industry focus as well, and a very simplified map of our process. Our business focus is to be the graphene supplier of choice for you by adapting your volume requirements and the presentations that you need, specifically the ones you need, and as well getting closer to people that is required for this process from point zero to the new product. Our offer consists in 2 potential outcomes. The first one is focus on the supply of graphene oxide. As well, we also are providing reduced graphene oxide and graphene nanoplates, depending on what characteristics and the performance you would like to have on your new product. Everything regarding the regulatory and logistics will be handled by us to deliver the product on the timely manner for you. The second part is to create a micro ecosystem for you. What I mean by this is to get the expert people just in the process to development of the product close to you. And here we have three options. The first one is if you choose to have the help of research centers in Mexico with whom we already have agreements with, you can do that. The second one is to get support from the research facilities. As you might probably know, many of them, they have their own research areas, and they can offer these capabilities as well to our clients. We have one in North Mexico in a sister company, and the ones in the US. And the third part is a collaboration with the Manchester University, thanks to the collaboration that the Graphene Council has, very, very well achieved goal, to expand this benefit to its members, to have a special rate for their services in development products. And we can extend that as well to our clients. To give you just an example on how we are developing this, we are focusing in these different areas, the different industries, as you can see it in the slide. And mainly, we have been having much more results in the mining, in the paintings and coatings, in the construction and the steel valves. An example of this, just to let you know how it has been deployed during the last months, I would like to talk a little bit about some of our customers that are currently in development with graphene products. Mackenzie is a company that gives service to hydraulic systems and has been testing graphene into steel valves to avoid mechanical wear. The results have been awesome, and they are very, very advanced on this. The mining consortium are also testing the graphene varnish to avoid mechanical wear as well. As you can imagine, their equipment need continuous parts exchange. And with this coating, they have been delaying the time between maintenance services, which is a great result for efficiency. HIJ is a construction company and is studying the application of graphene in the reinforcement material for the structural support. As well, they will develop waterproof coatings into their structures as well. The fracking company we are collaborating right now is testing graphene for mechanical wear into their gear systems, which is a challenge because of thermal increase or temperature increase during the operation. The coatings company right now is more focused into corrosion and salpeter resistance, and they are focusing on the shipping industry. So as you can see, graphene plays a key role in improving the characteristics and the capabilities of the product that you already have, or the material that you already have, and enhance it or gives extra characteristics to the product in a diverse set of industries as well. Just to give you a glance of our process, this is a very summarized one. We have from our graphene suppliers here, the shipping of the product, and we get all the customs and regulations already in place in Mexico, and have the quality assurance for the product that we are receiving. We have two warehouses, one in North Mexico and one in Mexico City, where the product is received. And once it's received, we can wait for the client to request a specific material. By requesting it, we just distributed it, but according to the country regulations, depending on where we are distributing it. But the key point or the key message that I want you to have from here is that we have the leverage for a lower price due to the volumes we buy, and that makes Glaren to have a better offer to its clients. I would like you, just to end my presentation, to get this final reflection. Right now, there are a lot of companies that are already developing new products, testing materials with graphene, and doing a lot of things with graphene and having great results. So I wonder, where would you prefer to be? In the leader side or in the follower side? Thank you very much for your attention. Here's my contact information. There's my email and my phone numbers, so please free to contact me to any questions. Thank you.
Thank you, Belen. Appreciate the presentation. And again, this kind of shows the practical side of actually working with and commercializing the material. So thank you for that. And it's good that people know that your services are available. And with the next, we're going to move on to Carolina from Carbon Up. And this will have a little different take about the services that your company provides in how you're working with functionalizing and manipulating graphene for end application.
So I would like to thank you, the Graphene Council, for the invitation to speak with all these speakers here today, and to have this opportunity to present Carbon Up and our developments that we are doing here in Brazil. So basically what we bring here today is we would like to present a little bit about Carbon Up, our journey, how we work, our market segments that we are planning to achieve here in Brazil, and some cases of the use of graphene that we are developing now. So basically, we are a Brazilian startup that wants to connect the graphene with the final consumer through the solutions that result in performance in use and cost efficiency. We have much approach with the customer, so we can understand how we can apply the graphene, not just with the performance that this product could make, but all the benefits that could bring and results in a new developments, not just for replace materials, but for the innovative materials too. So we have an expertise to the characterization and classify the graphene. We have contact with global suppliers of graphene that sells different grades of graphene. And we developed some roads to incorporate graphene in thermoplastics and thermoset materials. And now we have a development in painting additives. So I would like to share with you some cases of these developments that we are doing. So our location is Brazil, in Brazil. We have a head office in the city of Campinas. We have now a partner factory in the city of São Paulo and Rio de Janeiro. So this is our team. And to explain a little bit about our journey, in 2019, we received a financial support for an angel investor. She's Paula. She's an angel investor for Harvard Business Angels. And we start to develop the suppliers, not just to understand how graphene is in the market, but how is the quality of this material and how is the prices of this material. In the meantime that we are doing that, we start to understand the market segmentation here in Brazil. So we clusterized the Brazilian market and could receive the graphene for their applications. In the meantime, we did some lab and pilot developments to understand the performance in use and the cost inside the formulation. Does that make sense for this kind of customer? We can use this in disruptive innovation, or we can replace for other materials. So we did some joint developments with some partners and some customers. Now we are very happy because we have a partnership with a master batch company, and we are doing a study and understanding the market that we could achieve with the appliance of graphene. So we are focused on the priority markets that Brazil could receive this technology. So to explain a little bit in how we can work, Carbon Up works since the research and the development to the sales and production. We know that we have our own developments, but sometimes customers here in Brazil have some contact with us and they want to understand, how can I apply graphene in my products? Sometimes we need to have this approach because we need to understand how is the process of the customer. Is graphene is the better choice to use in their pain points? So we can work since the research and development, analyzing all the supply chain, even for the suppliers and the market potential of the application. Okay, we are doing an innovative development, or do you want to replace some material? What is the cost efficiency of that? So we are able to do all this analysis with our customers since the laboratory tests to prototype and understand how we can upscale this technology and how we can do this really turns on sales. So we have some segments that we did some clusters here in Brazil. So we decided to invest in 7 segments here in Brazil. So inks and coats, we have developments for anti-risk and anti-corrosion coats, mainly for powder coatings. I will explain a little bit more in our cases. Active packaging. So we did some developments now here in Brazil. We identify that we could develop new products with long life cycles, packagings with long life cycles, and more barrier properties. This is a good market here in Brazil, and we identify there is a lot of customers interested to do that, to see the innovation and to put this innovation here in the market. We have a line that we are working with green tech. So we understand that we have a lot of recycled plastics here. So this is a cheap raw material, and how we can turn the cheap raw material through innovative products with high value aggregated. So besides that, we have developments in 3D printing filaments to increase the resistance, the mechanical resistance, and for conductive filaments. So we are in the phase of the first trials now. We have two segments that we say there is special additives and functional compounds, but basically these segments we divide because it depends how we can deliver the product for the customer. So there is a powder additive, it's a master batch. There is something that we always looking for because we realized that if we can come to the customer just for, oh, this is graphene, this is graphene oxide, and you have this better performance, this doesn't work. So we need to understand how is the pain points and how is the innovative developments that they want to do and they want to receive. And we always do this balance of the performance in use and the cost efficiency. And we have an arm too for lubricant properties. I mean, not oil properties, the oil lubricant properties. We actually have experience now to work with some master batches that could improve lubricant that results in a better production process and production and optimizations of these productions. So we have our developments that we have a line that is a green carbon line. This is a 3D printing filament that comes from a recycled plastic. We could increase 15% of mechanical resistance and decrease 20% of density. This is a glass, a prototype did by 3D printed. And now we are understanding how we can apply this technology in the market, who is the customers that could pay for this technology. So, and besides that, we have our line for functional compounds. Basically, we are working with polyolefins, polypropylene, and high density polyethylene. And for some other polymers for nylon 6 and ABS 2, the main goal to achieve better mechanical properties. So just to give you a brief about our cases, we have some results from next week, and we are very happy with these results. But we started a development now with additives and paintings for powder coatings, and we achieve very good results in trace corrosion. So we can increase this anti-corrosion in 50% using some grades of graphene. And for our surprise, with graphene oxide, we increasing even more. So this is our first trial. We are doing this in a collaboration with a partnership. And we are very excited with this result because we see that the cost efficiency and the performance in use could be very no apply in the market. So the performance that we are looking here is the anti-risk, anti-corrosion. And now we see that with graphene, we could partially replace some already used raw materials. And this could result in a total cost saving of the product. And we can reduce the stocks and raw material as well. So this is on a development that we are very excited to go on because we see good market possibilities here in Brazil, not just here in Brazil, but it's a technology very good applied here in Brazil. So our case that we have, it's the improvement that we start to do in properties, basically in polyolefins. So with polypropylene, we can adjust the melt flow index using graphene and graphene oxide. And this is very a good result because we can also work with operational management efficiency. I mean, once you have to work with a low melt flow index, you can achieve for one grade. And once we have a better properties but the same properties, but different melt flow index for injection molding, I mean, you can use two. So this is something that we are looking on. And for the impact resistance, yes, we did some formulations with graphene, basically with graphene nanoplatelets, and we achieved some better impact resistance. We know that to enter in the market, we need to show a very high performance. So what we are doing now is compare with the impact modifiers that already existed in the market, and we are having some good results in terms of cost and in terms of performance. So going a little bit fast, this is an improvement that we are very anxious to apply, because we make some formulations with polypropylene and high density polyethylene. I'm sorry for the Portuguese, it's high density polyethylene. And we achieve better properties in terms of antioxidant properties. So what we basically did is we work with a pure polypropylene. There is the OIT time is 1.04, and you could increase for 300 minutes. That means that we could have a space to work in agribusiness sector. I mean, for films, for tubes, or for wires and cables. And there is a very good opportunity. We know that the market size here in Brazil is very big. And now we are understanding, I think there is a lot of companies of graphene, and even for the people that are doing this the same as Carbonup, that developing new products has the same problem, is the color of the graphene, cases of the polymer matrix. So it's something that we are studying in how we can apply this on the market on the right sector, because the color is an issue for us now. And we have some barriers to enter in some kind of markets. So, but the results are very good. And with a small amount of graphene, we can achieve these results, and we have an entire market to apply this technology. So, in terms of mechanical properties, we know that it's not only just apply graphene in the polymer matrix. So we did a lot of experience in different incorporation routes. So as you can see here, when we are talking about the impact resistance with ABS, we try two routes, and the route that I named here A, we have decreased the property, and the route that we call it here B, we have a lot of increase. So one of things of the Carbonup studies is, okay, we have the process of the customer, how much costs to I deliver this raw material, and how he can apply, because if they don't apply directly and correctly, they don't have the performance, so we don't have the expectations of we are selling. So in the meantime, when we are talking about nylon 6 polyamides, we have this difference too. There is two ways that we are looking to develop this master batch. So if you compare A and B, you can see a difference, but you can see that we can increase even for tensile modulus and tensile strength. So this is a good result. And we are keep going with this development, because we strongly believe that for engineered polymers, it's a good market to develop graphene and graphene oxide. When I talk about graphene, not just only a grade of graphene. We know that we have a difference of graphenes. So we studied this difference of graphene, how we can apply nanoplatelets with 10 layers, 7 layers, what is the difference that we can achieve with that. And so we did what we called G10. It's internal formulations that we do here to understand how we can apply this nanomaterial inside the polymer matrix, or even for the powder coatings that we are working with some polymer matrix too, and how we can apply that, and how we can the better performance, and how we can sell this to have the balance that I spoke. So here in Carbonup, me and Andressa, we are from materials science. I am a materials engineering. I have a master's degrees in materials engineering and nanotechnology, and Andressa is a production engineering and have master degree too in materials engineering and nanotechnology. Now we are doing our PhD in materials engineering and nanotechnology. So you can see we love materials engineering and nanotechnology, and it's very good to work with what we love. So. And our investor is Paula Tortolo. She is part of the TR Investments. It's a group that invested us, and believe in our developments. So she's take care of all our strategy, even for commercial strategy and business strategy, so on. And besides that, we have a network of mentors in the industry factory and the commercial and market segments that could grow up us to be ready when you can do this technology for the market. So this is something that I would like to share with you today. I would like to thank you again, Terence, for this invitation. For us, it's an honor to speak with all the speakers that was in the meeting today. So if you want to take contact with us, there is our contact email, our website. If you want to contact us directly for LinkedIn, please feel free. And thank you again.
Absolute pleasure. Thank you, Carolina. And I think collectively, if we look at everything that was presented, and I'll invite Flavio and Danielle and Belen to, you can put your video on and your audio so that we can go through questions. We do have quite a few questions. And I'd like to start out asking Flavio, for example. There was one thing in here, I don't want to lose sight of the importance of it. You talked about a characterization methodology that combined the Raman with the AFM and being able to do quite a large number of sample size. If I understand correctly, it's a fairly rapid process. To me, that sounds like a game changer, because using AFM, of course, is an excellent methodology for determining the actual layer count. And I think you mentioned in your presentation, using Raman, you can kind of infer how many layers, but it could be misleading if I understand correctly. So can you just talk to me briefly, if possible, about this process? And for example, how long does it take to do a sampling, and what kind of numbers are you getting, number of flakes that you're measuring? Because it looked like it was an exceptionally high number. And this could be a really important tool for producers for batch-to-batch quality control. It's really interesting.
So first, the AFM, we measure like 10,000 flakes, okay?
10,000, okay.
About 40 minutes, to take the image in the AFM, and the analysis is just like minutes, seconds, I don't know. You just upload the image, the AFM data to this smart system, and it will do everything. Every flake in the image, you have a catalog number. You can go to each flake and know what it is. Everything is automated. So first, we develop the way of preparing the sample. Of course, if you have a dispersion, you have a sample in the substrate that is representative of what you have in the dispersion. So we develop a method for preparing the substrate with the suspension. Prepare the substrate, you put in the AFM, you do your 40 minutes image, and that's it. Upload the data, and in a few minutes you have everything. You have this histogram, all the data. And for the Raman, the same thing. Professor Luis Gustavo, that is the responsible for the characterizations, is a very well-known specialist in Raman spectroscopy. And you do the same thing. We put the sample, we measure like many flakes, thousands of flakes, and all this data, all this Raman data, finds a Raman image of the sample. It goes to a system that does a PCA, that does how we call that, is a principal component analysis, and the principal component analysis was calibrated, with standards that we built, and then each sample in the PCA will have its own shape, and from that you can get the histogram. And the thing is that the Raman, it sees the electronic coupling. If you have like 5 layers of graphene on top of each other, but they are not electronically coupled, if they are a bit loose, or if they are rotated one in relation to another, the Raman won't see 5 layers. It will see 1 layer or 2 layers. So this is what Raman sees, electronic coupling between layers. AFM, on the other hand, sees the thickness.
Yeah.
No? So there are those two informations have to be look. No, Raman is a very like no. You see many people call it Raman data. I have 2 layers graphene. This is really misleading.
So
No?
Flavio, I think you and I need to have a chat because we did a whole webinar just on characterization of graphene early in this year, and I think we need to do another one because this is kind of a groundbreaking development that you've had, because normally the AFM is for a very few number of flakes and it takes a long time, etc. And there's a lot of work being done right now in standards bodies, specifically on characterization methodology, both for characterization of samples. But what's missing is in the production batch-to-batch quality control measures. And so I know we've had quite a bit of time already, but I just want to put a pin in this, that this is something we need to come back and to explore a little bit more.
Yeah, then we would like to talk with Luis Gustavo Cansado. That is the characterization package, coordinator.
Okay. And
then he'll be more than happy then.
Excellent. What I'd like to talk about now or ask questions about, I don't want to lose sight of the fact that Brazil is about a 1.7 trillion GDP market, and Mexico is a 1.1 trillion US GDP market. These are the 2 largest economies in Latin America. Both of them have excellent automotive, aerospace, agriculture was mentioned by Carolina, sectors that are really, really important. And so Danielle, talk to me a little bit about what you're seeing from the McGrath Institute. What is the biggest barrier to commercial adoption, in your opinion, from your perspective? And you sit at that interesting juxtaposition between academia and the commercial side, much like the Graphene Engineering and Innovation Center in Manchester. And I'm conscious of the fact that we have Ivan Buckley in the audience. Okay, so a shout out to our good friends at Manchester with whom we work with. But you guys kind of, I think you have a similar model, and it's frankly, from my opinion, it's the smartest tech transfer approach I've seen. Is this innovation and prototyping type application between academia and industry? So, what do you see from your perspective there in Brazil?
Oh yeah, actually, it's something really new in Brazil. So this model of to bring the companies inside the university and to have this long-term relationship with companies, it's something that it's new. It's I would say that sometimes it's brave because companies in Brazil they usually they always comes, okay, so I will going to put some money with you, but how many I will get after. So they don't really want to take a risk, and I kind of understand, but sometimes they really to take some risk, and I don't know if there is not so good how to say that benefits from the governmental side as well. Maybe it could be a little bit better, and sometimes it's a little bit hard to build up good contracts with the companies, because how to share the property, intellectual property, things like this. So we're now starting to do it a little bit better. So what we're trying to do now, it's to try to build up more flexible NDAs and MOUs, and in order to provide better agreements, and then if the company wanted to do a development with us and they don't want to share the intellectual properties, okay, so let's try to find a way to do this. Or if they wanted to spend that much money, okay, let's try to do this in like sharing the properties, and try to arrange a way to do that as royalties in the end. So that's a way we're trying to do. So being more flexible and try to be more comprehensive with the companies and try to bring them to the university. And ask them to think with us. One of the things we're doing with our partner, when we call this partner one, we invite them to actually, we're going to give to them a share in our board. So they will participate in our board, they will participate doing advisory in us to make our decisions in every 6 months. So I think that's good for the companies.
So Daniel, what I would say, and this is in general, we see very large major companies, and we know that they're actively working on graphene. And this would be my message to any companies that are looking for application development. Graphene obviously comes in many different flavors, if you will, that need to be tuned to a particular application. And it is certainly faster, cheaper, and less risky for organizations to work with bodies like the McGrath Institute, like the Geek in Manchester, like working with the Graphene Council as an intermediary to put the supply chain together. It's much cheaper, faster, and less risky for them to work with organizations like yours to get through to that application development than it is for them to try on their own, because we've seen companies in the past try to work with graphene and fail. And they failed not because the material was bad, they failed because they didn't understand some of the nuances of how to actually work with this material. Belen, if you don't mind, I'd like to ask you a question. Is, what do you see, on the regulatory side or with customs and that sort of thing with importation? I know in the United States, we were just on a call this morning talking about some of the difficulties with the regulatory environment. There are different schemes in Europe with REACH, et cetera. What are some of the biggest barriers you see to actually importation or transport of graphene materials?
I believe it's not really the customs and the regulatory affairs like that. I think that the big challenge is the transportation of it, as it is a very what we call hot merchandise, and in Mexico that part is sometimes risky to travel by truck or by earth. So whenever we have these larger amounts, we have to take care of that. That's going to be the biggest challenge, at least here in Mexico. I don't know how it is in Latin America, but I believe these challenges are as well important. If it goes through air or sometimes by sea, by sea, I think it'll be less if it's closer to the location. So the customs is actually not that quite difficult. At least in Mexico, it's very, very kind of well known. It's very close to graphite. It doesn't have like today great blockages to get in.
Okay. And just to point out that you're, as a distributor, you're working with different suppliers of different grades of material. So you have a little more, let's say, range of product that you're accessing.
Right. Right. That's it. That's the important part. Like we can deliver mostly, we are focusing right now with 3 kind of graphene, but we can have any quality because we are talking with the suppliers, and we have here in Mexico, we have our own sister company that produces graphene oxide in a very high quality part as well. So we can deliver all those.
Well, the other thing I want to emphasize for everyone, again, for the audience that's listening, that there are literally hundreds of companies that claim to produce graphene. And if you look at closer examination, either from quality control issues or you look at scalability, the amount of product that they can produce, then the number of commercial grade graphene producers is a rather smaller universe. And that's one thing that the Graphene Council tries to monitor and pay attention to. It also is our due diligence. And we do run a verified graphene producer program to actually physically inspect production facilities. Carolina, I'd just like to talk to you a little bit and get a question in for you before we have to close our webinar today, is on the performance improvements that you've seen. You talked about PA6 nylon, for example, which is quite interesting. You talked about other, I think polypropylene, I'm not sure, or ABS, I think was the material on impact resistance, which is really important for the automotive industry, for example, or for aerospace applications. What kind of load factors are we talking about? Because I think that's the other thing people need to understand. I think in Flavio's presentation, we were down to 0.1% on some of the load factors. What is the least amount of graphene that's been used to show these improvements? And just one other point on top of that, I think it was Flavio's graph or one of the graphs. It showed that 1% made an improvement, 0.5% was better, and 0.1% was the best result. So using less is more is the rule with graphene. So Carolina, talk to us a little bit about these load factors and why is it that you think that using less is better with graphene? Because it's counterintuitive.
Yes. Okay. Yes. Here in CarbonUp, we are using less than 5% because when we are developing, we need to understand with the master batch and the final composite. So sometimes you need to load the master batch and you do the applications in different loadings. But yes, Flavio is correct. We have some good results even in for barrier properties, the less than 0.5% of graphene. And when we started to work with higher loads, we have some problems. So sometimes we have this percolation, and sometimes what we have in mind here is not that if we add a lot of graphene, we will have more performance. So we need to identify the best percentage for each application. So sometimes what we have here, 0.5% for one market, is very interesting because we have the performance and we have the cost efficiency. But sometimes for other markets, when we are talking about with polyolefins, we need to be careful with this percentage, because if we can increase a little bit the percentage, we have good performance, but the cost efficiency of that is not good, and the market doesn't receive this technology. So this is something that we always analyzing with the difference of the percentage, the application, and how we can incorporate this in the market, even showing the performance in using the cost efficiency.
Excellent. Well, we have a lot more questions, and I know that we said we'd be here for 90 minutes, which is already passed. It's gone really quick. So for those of you who have to drop off, I fully understand that. And I would just ask our panelists, are you okay to take one or two more questions?
Yeah,
I'm okay.
Oh,
I need to leave. I'm sorry.
Yeah, Belen, I know you have a trip coming up and such as that, but we had some there's a couple of technical questions and such about production methods, and I didn't want us to drop off without asking maybe just a couple more. So Belen, thank you so much.
Thank you. Thank you very much to all of you.
Thank you.
What is it? Bon viaggio, or what? Have a nice trip.
Buen viaje.
Okay, take care.
Bye.
Thank you so much. So some of these questions, I think I'll go to you, Flavio, again, talking about getting back to some of the characterization. So we were talking about Raman together with AFM. Another method that's been used quite a lot, and I know that I've seen some companies use it as a proxy for layer count, is using BET and surface area. So they'd say if we've got, if we have 2,360, then it must be single layer, and if it's half of that, it must be two layer, et cetera. And I know that, and I think I'm speaking accurately when I talked to Dr. Andy Pollard from the NPL in the UK. His opinion was that BET is not a really useful tool for layer count, used as a proxy. I'd be curious to understand what's your opinion about using BET for a characterization method for graphene.
Yeah, my opinion is the same. I mean, BET is also extremely misleading. And again, you really have to talk to Luis Gustavo, because he's developing, a method, way better than BET to do the same thing. Mm-hmm. So he's under development, so it can't be disclosed. But we are developing within the project. Luis Gustavo is leading that. For a method to really be sensible to how much surface of graphene you have in the material. But we don't use BT. We don't rely on BT to do anything, any characterization.
Yeah.
And in general, we take it with a very high degree of culture.
So the flip side of this, and maybe talking to some people who work with epoxies and resins and liquid systems, the surface tension and surface area is important for them, also for rheology and aspect ratio. Carolina, can you talk a little bit about? Surface area is often quoted in a lot of the spec sheets for commercial graphene materials. What's your perspective from that viewpoint? How important is surface area to know then for handling the material or for dispersion?
Yes, well noted. Yes, the surface area is very important to different applications, as we are working with these powder coatings, and not just for powder coatings for liquid phases. We have seen in the market that is some suppliers, they have difference of the surface area, and when we can work it sometimes in the middle of the surface area of some products that they can deliver, we have good results. Surface area is very important to understand how we can do this performance in the final application. But sometimes when you look in terms of price, you have difference of price if you have higher surface areas, and sometimes you need to analyze if, okay, I can apply less surface, a grade of less surface area, and I have the same performance. So this is something that we are always looking for to determining the end of the application.
Yeah, excellent. And Daniel, I have a slightly different question for you. Some in our audience are asking about, training and education. As I'm fully convinced that graphene is basically the creation of an entirely new industry of two-dimensional nanomaterials, advanced materials that require specialist labor force, right? We need people who are trained and understand this. What do you see? Is there support from the government in Brazil to help support this sector? Mackenzie University, as a nonprofit university, has a little different because you're outside of the, let's say, that state system. What do you see in terms of opportunities or strategy from Brazil for training a workforce to deal with this material?
Oh, in principle, we all the time we see programs that it's dedicated, to develop products and research and things related to advanced materials, not only 2D materials, but other kind of materials in Brazil. And that includes universities, private universities, but it has to be non-profitable universities as well. Not only public universities, but non-profitable private universities can be part of this these programs that comes from the government. So we are included. So of course that 2020 it's a hard year for everybody, but we believe that quite soon that we're going to have something available again, and we are preparing now to write grant proposals, and of course we wanted to do research, but one of the things which is really important for us is to train people. So Mackenzie, the most important things of Mackenzie is the education thing. So we have students since the kindergarten to graduation students, and of course here at McGrath we have graduated students. So Carolina is one of them. So she's here.
Nice work. That's a good.
Since undergrad. Since undergrad.
Yes. I'm Mackenzie. I'm a materials engineer from Mackenzie. Yes.
Yeah. So, and that's really important for us to provide, more space for people to be trained to work with 2D materials, and we have plenty of space for them to work here. And we wanted to have not only governmental grant for that, but we also we're also saving part of the grant we receive from private institutions to provide, a grant for students to come here and study with us. So that's
Excellent.
something that's important to.
Excellent. Well, I wanted to get in just a couple more questions there. So thank you guys for staying with me for that. I want to make the observation, if it isn't obvious already, that the main focus on graphene development, a lot of it has been centered in Europe, obviously, with the graphene flagship and the funding and the strategy there. There's a lot of activity, obviously, in the United States. And I want to make it crystal clear, there's obviously a tremendous amount of progress being made in Latin America and in Brazil in particular, with both MG Graphene, with the consortia that you have there, with the McGrath Institute, and then you see the follow through on these startup companies and distribution networks for the material. So the Graphene Council, from my side, we're very excited to be engaged with you. We're very supportive of all the efforts for the industry there. We think you have tremendous opportunity and a natural advantage with so many graphite mines in Brazil, and it makes perfect sense to develop it. So before we close, and I'll start with you, Flavio, did you have any closing comments you want to share? And I want to thank each of our presenters for excellent presentations and putting in the time and effort to prepare for today. So Flavio, any closing comments?
Yeah, my comments is that we are available anytime. We can talk. I will try to not to answer all the questions here. In the Q&A, and I'll do that. And
Yeah,
my comment is that there are some questions about scalability and about separation process. And the comment I will make is that, for example, for separation process, of course, I can't go into details. But in the project, we use only very standard industry technologies. So separation is done through centrifugation. Where the secret is, in what kind of centrifuge you use, how you set up the centrifuge, what are the details, how you do the process. But this is why the process is scalable. We don't take rocket science equipments and things like that to make the process work. We use equipment that we can use for 100 liters batches, but equipment that if you want to buy it, then you have suppliers that can make it for 10,000 liters batches. So yeah, this is an effort we made in the project. So the secret is really how to choose the equipment, how to set up the equipment, some details in the process. This is where the tricks are.
Excellent. Well, I know we need to have another session about this, and you have a wealth of knowledge, which I appreciate you sharing. We wanted to just get an overview of what's going on with graphene in Latin America with today's presentation, and I appreciate you joining from what used to be my home country in Switzerland. So thank you for joining us from Lausanne. And Danielle, do you want to have any closing comments?
Well, first I wanted to thank you to the opportunity and thank you for the partnership you're doing with us. I know that Brazilians sounds a little bit like aliens, but and the Brazilian markets, it's a little bit strange, but I believe that we can build up something really good and something really different in order to understand what's the market and what can be developed in Brazil. I know that I'm sounding a little bit like a businessman, but I still a old school physicist. And I still like, go to the lab and, to do my research. And we have a whole building here with facilities to do characterization. And we wanted to, collaborate in Brazil and abroad. And we have a really, really good relationship with the universities in Brazil and plenty of friends in a different part of the world, then we believe that we can do great here and we can collaborate a lot. So thank you, and thank everybody, and anything you want. So I'm available here.
Well, thank you, Daniel.
Cheers.
all this wonderful stuff that's in the lab doesn't do any good if it doesn't make it into products and into commercial use to improve people's lives. And we should never lose sight that graphene has this tremendous opportunity to reduce energy input, sequester carbon, make things lighter, better, faster, more recyclable, etc. So there's so many benefits that we really can take advantage of in our economy today and improve life. So we're really happy to work with you on McGrath to make that happen. And Carolina, you're an example of that, like going from the lab and now bring this to life. I think we're well past the point where graphene is a laboratory curiosity and it is now ready for commercialization. So we need to take that next step, and companies should not be afraid that this actually works, because we know it works. We have enough data to know it actually works. So how about from you, my friend, what are your closing comments?
Yeah, Terence, I also think the same way. I think Brazil is ready to receive this technology. Once we have these improvements in the development of the performance in use and the cost efficiency. So yes, I would like to thank you for this space to talk a little bit about Carbon Up. We are available for the questions. We are available if you want to text us via LinkedIn or even for email. And thank you for all the speakers today. It's an honor to be here. And yes, and that's my final comments, Terence.
All right. Well, on behalf of the Graphene Council, we're very happy to have hosted today's webinar. We appreciate your time. Thank you for everybody who stayed with us to the end. And I know we still didn't answer every question, but this is an ongoing story, and this isn't the last time that we're going to address this. So thank you everyone for attending. And with that, we are going to close today's webinar. Thank you. Take care.
Thank you. Bye-bye.
Okay, bye-bye. Thank you very much.